So far, we have been using the notation of equal. We have been using the equal sign to talk, for example, about f equals O of g, right? F equals O of g. But if you think about it carefully, you will notice immediately that we are abusing this notation, the equal sign. And the reason for that is that if you look at the big O of g, it is not a function. Big O of g is not a function. When I say f is big O of g, I am saying there exist constants c and k such that for every x greater than or equal to k, f of x is smaller than or equal to c times g of x. Now this is not a function. You can find so many functions g, so many constants, and you can find many functions f that will be O of g. So this notation here, f equals O of g, is really abusive notation. The right thing to think about it is that O of g is really a set of functions. It's the set of all functions h of x. So let me drop the x from here. It's the set of all functions h such that there exists c and k, such that for every x greater than or equal to k, h of x is smaller than or equal to c times g of x. Okay? So this O of g is really a set of functions. So how can I write f equals a set of functions? How is a function equal a set of functions? The right notation is f is an element of O of g of x. Okay? This is the right notation, and this is completely mathematically correct. F equals O of g is just we are abusing the notation, and the reason for that, it's been used like this for over a century, and we don't want to change it now and start using the element of. But please be careful about this equality in the sense that you cannot say that O of g equals f. This makes absolutely no sense to say O of g equals f. Okay, we don't have that meaning. So don't use this equal sign the way you would use equal sign, naturally. Two numbers are equal. You can of course write a equals b and b equals a. Here, don't say O of g equals f or little omega of g equals h, okay? And the last word I want to say in this video is about the equivalence relation that is defined by asymptotic equality, or theta. So if we define theta as a binary relation on the set f of all functions, for our purposes, a set of all asymptotically non-negative functions. And what do I mean by that? If you put, a pair, if and g are in this relation, if and only if is a theta of g. If you look at this here, you will notice that this relation is reflexive because every function is a theta of itself. If you take, for example, c1 and c2 and k, all of them equal 1, you'll be able to show that f is greater than or equal to c1 times f, smaller than or equal to c2 times f for every x greater than or equal to 1, right? It is also symmetric. So if f is theta of g, then g is theta of f as well. You should be able to prove this. It's a very easy, very simple result. If f is theta of g, it means that there exist constants, c1 and c2 and k, such that f is bounded from above and below by c2 times g and c1 times g. Then we can bound g from above and below by 1 over c1 times f, and from below by 1 over c2 times f, and so on for every x greater than k. And it is, of course, transitive. So if f is theta of g and g is theta of h, then f is theta of h. And again, here you can use the notion of the product of these constants, right? So if f is theta of g, then f is smaller than or equal to c1 times g. G is smaller than or equal to c2 times h. Then f is smaller than or equal to c1 times c2 times h. So this makes f O of h. The same thing we show for f is omega of h, and then we get this theta result. Okay, so this is a very important result. This shows us that if for example, when we think about all the integers and the binary relations, the binary relation of two integers are equal if or equivalent if they are equal mod 7, for example, and that partitions the set of all integers into 7 equivalence classes. The same thing here, this equivalence relation of the asymptotic equality big theta, it partitions the space of all functions such that every equivalence class is the set of all functions that are theta of each other. And this is very important here because especially the symmetry in this case, if f is theta of g, then g is theta of f. So you can actually lump all functions that one is theta of the other. You can lump them all together and say these are in some sense asymptotically equal or asymptotically equivalent.